So friends, today's class is about Hadoop installation on multiple machines. So we'll be starting with the agenda. The agenda is install multiple Ubuntus, because for installation of Hadoop on multiple system, we will create multiple Ubuntus on our single laptop for learning purpose. Set up IP address on multiple Ubuntus. As you know that master and slaves are interacting with each other, so those multiple Ubuntu should be interacting with each other. We need to set up the networking between the multiple Ubuntus. Modify host file, modify masters file, modify slaves file, passwordless SSH from master to all slaves, and passwordless SSH from all slaves to master. Modify other configuration files. Copy Hadoop setup to all slave machines. Format Namenode. Start Hadoop services. Check Hadoop services and stop Hadoop services. So this is the agenda for today's class, and you will be able to correlate when we install Hadoop on single machine, and today we are talking about how to install Hadoop on multiple machines. You can correlate what are the differences. So friends, let's start with the first one, install multiple Ubuntus. So while installing Hadoop on single system, we have already talked about how to create Ubuntu on VirtualBox, right? So what you can do is, using VirtualBox Manager, you can install multiple Ubuntus. You have that file with you, that ISO image file, that soft copy of bootable disk, right? Using that image file, you can install multiple Ubuntus, give some different name. Maybe you can give like Ubuntu 1, Ubuntu 2, Ubuntu 3, or maybe you can give the name like slave 1, slave 2, slave 3. You can do that. Make sure that the operating system on all Ubuntu is same. Very important thing. We say that we need a Linux based operating system. That's true. But one system is Linux, one system is Mac OS, second system is Ubuntu, third system is Red Hat. That will not work. Exactly same operating system should be there on all the Ubuntus, and make sure that the username on all Ubuntu is same. That's also important. So you can choose a username, maybe Hadoop. So you can create that Hadoop user on all the system, so that those machines will be interacting with each other through that particular common user. Apart from that, install Java and SSH on all Ubuntus. It's obvious thing, right? Java and SSH are prerequisite. So you have to install that on every system. By default, multiple Ubuntus cannot communicate with each other. Very interesting point. By default, the default behavior of Ubuntu is that Ubuntu can interact with your Windows. Windows is the host operating system and Ubuntu is the guest operating system. So host and guest can interact with each other. But multiple guests, multiple Ubuntus cannot interact with each other. We have to do something for that. Like, just like if multiple guests are coming to our home for some party and they don't know each other, but they know us very well, right? If we can introduce themselves, they can also know each other and they can also interact. Same thing is here. We have to do some setup. We have to make some networking changes, and after that multiple Ubuntus will be interacting with each other. So we don't really need multiple systems for doing these things practically. We can install multiple Ubuntus on the same laptop itself, and then we can practice. The only thing is, multiple Ubuntus will use multiple resources. Suppose you have only 4 GB of RAM, right? And you have Windows, which will consume some RAM, and suppose you have 2 or 3 Ubuntus as well. So ultimately 3-4 operating system will be running parallelly on your system. Sorry, that would be consuming your resources and your system will be little slow. That's the only challenge. Otherwise, as far as possibilities there, it's possible to install multiple Ubuntus on the same system and set up a multi-machine Hadoop cluster. Okay, so how to do the setup part, the networking part? Let's move to the next slide. You can see this step by step I have given, and you can even have a look at the this screenshot. The first step, you will click on setting. Second step, you will click on network. Then there is adapter 1, and there are few changes you have to do. You can have a look at this. Open VirtualBox Manager. Right click on each Ubuntu one by one. First Ubuntu, click on setting, go to adapter 1, change, you can see this, select this NAT, then click on advanced, click on refresh button on MAC address. Similarly, you will go to adapter 2 and change the setting and again click on refresh button on MAC address. These two settings, changing the adapter 1 and adapter 2, you have to do on every system. So I have taken a screenshot as much as possible for your convenience so that you don't have to struggle for this. So using these steps, you can follow this. After that, click on OK. Start all Ubuntus. Now you can start Ubuntu one by one. Open the terminal and type ifconfig. Ifconfig is a command to check what is the IP address of that system. If you are getting the IP address starting with 192.168, that means you have set up the IP addresses. You have set up the networking part successfully. You can even check whether one Ubuntu is pingable from another Ubuntu. These slides are more of networking stuff. As a Hadoop guy, in real-time scenario in office, you never have to do this. Your networking team will do that for you. Your system will be ready with Java, with SSH, with all the networking and all that. You can start directly with Hadoop installation in real-time scenario. But when you are doing this thing on your system, even the networking part you have to do. That's why I have added these slides which will help you to set up the IP addresses. So what you can do is type ping, P-I-N-G, space IP address of another Ubuntu and see if it's pingable. So all systems are connected now and all Ubuntu should be pingable from each other. Okay, so this is all about the networking part of multiple Ubuntus. So after networking part, we have the next thing, that is modify host file. Host file is like containing mapping of IP address to host name. IP address is a big number. I think 12 digit. Remembering those 12 digit is not a good idea because there will be some typo and your Hadoop will not be running properly. Just like we cannot remember our 10 friends' mobile number. We can't do that. But we can remember their names. That's why we store their number, contact number, along with their names in our smartphones. Right? So if I want to talk to Anurag, I will simply search for Anurag name, not for the number. I will simply search for the name in my contact list and I will call him. But behind the scene, you are using his name to place the call, that's fine, that's for your convenience. But behind the scene, your phone is using the contact number to place the call. Same thing is there in Hadoop. When there are multiple machines and every system is having a unique IP, so instead of dealing with those multiple IP that's or error prone, what we can do is let's define some meaningful name to those IP. IP is having some meaningful name, suppose slave 1. Any name you can give, ABC, XYZ, anything. For example, let's have a look at this. You can open the terminal and you can type sudo space vi space /etc/host. Okay, and it will be asking for the password. The same password as your Ubuntu login password. You can enter that, and after entering the password, it will display like this. Starting from 127.0.0.1, the name is localhost. You must remember, when we were installing Hadoop on single system, we were doing SSH space localhost, or we were doing SSH space 127.0.0.1, right? Starting from first line till this IP6-all host. These settings are already there in your host file. We don't need to write anything for that. What we need to do is we need to add some lines here. You can see this. My Hadoop cluster starts. My Hadoop cluster settings start, and the last line you can see my Hadoop cluster settings end. These are commented lines, as you can see. The hash is there. Hash means these are commented lines. After that, you can see these three lines: 192.168.111.222. I am giving the name as master. Second IP, I am giving the name as slave 1. Third IP, I am giving the name as slave 2. These IP are just, I have written something like that, but in real time scenario, you have to write the actual IP. Go to the Ubuntu, type ifconfig, it will give you the actual IP and write that IP. As far as names are concerned, as I told you, you can give any name, it's up to you. Master or slave 1, slave 2, my slave 1, or any fancy name, you can give that. One more thing is that simply giving the name master or slave 1 or slave 2 does not mean that that particular system will be working as master and these two machines will be working as slave. No, it's not like that. We are not deciding which machine will be working as master and which machines will be working as slave in this file. We are not doing that. The purpose of this particular step is to give some meaningful name. If I am storing my friend's contact number with some celebrity name does not mean that my friend is a celebrity, right? But I know that I have stored my friend's name with that celebrity. That's fine. In the next slide, we will decide which machine will work as master and which machine will work as slave. Here, we are simply giving some meaningful name so that we don't have to struggle with these big IPs. That's the point. You can see the at the bottom I have written something. Repeat the same step on all master and slave machines. You have 5 slaves, you have 10 slaves, you have 4,000 slaves. Whatever number of slaves you have to make the required changes on all the systems. So friends, this is all about modifying the host file. So the next slide we have is edit masters file. When we installed Hadoop on single system, we did not modify any masters file, right? Let's talk about where exactly this file is located. So you know the files which we usually modify are always available in the conf directory. So we'll go to my local cluster home, we'll go to my Hadoop 1.2.1, we'll go to the conf directory and masters file. It's there. I will open it for you. So masters file, as the name indicates, should contain either the IP or the host name of your master system. As I told you on the previous slide, that simply giving the name master or simply giving the name slave does not mean that those machines will be working as master and slave. But giving the name in master's file, yes, that particular system which you will write here will be working as a master. And if you will open this master's file on your system, what you will find is you will find localhost. What does that mean? That means that by default, when we installed Hadoop on single system and we did not even modify master's file, that point of time it was having the entry localhost. That means by default localhost is working as a master. That's good. And that's why we did not modify that. But today we are installing Hadoop on multiple machines and we cannot go ahead with localhost. You know why? Because this master's file will be available on every system, master as well as slave. And suppose you will write localhost here, then every slave will read the master file to know who is the master, to whom they have to point, they have to interact. So every slave will read the master file, they will find localhost, and you know the challenge, every slave will consider itself as a master. Because that is the only way to find out who is the master. They will read the master file, they will find localhost, they will consider themselves as the master. But that is not true. We cannot have 10 masters in 10 machines cluster. We can have only one master. And that's why what you have to do is remove localhost from master machine and write the name of the master, whatever you have defined in etc host file. If you have given master, or you have given master machine, or you have given my master machine, whatever it is, whatever name you have given, write that name here. In my case, I have given the name as my Ubuntu. In my host file, I have written my Ubuntu here. That is about master's file. I am coming back to PDF. You can notice one thing, the last line, never use localhost in multi-machine environment, because that creates a lot of confusion and your Hadoop will not work properly. So we have used localhost in our single machine installation, that's fine. But now for multi-machine installation, avoid using localhost in any of the configuration file. So this is about master. Moving to the next one, edit slaves file. As the name indicates, it contains the name of the slave system. You can open the slaves file. It's again available in the conf directory of Hadoop. It's there, slaves. You can open it. And if you will open slaves file on your system, you will find localhost. Because the default behavior is your local system is working as slave. So masters and slave by default both contain localhost. That's why we did not modify this file while installing Hadoop on single system. But now what you will do, remove localhost from slaves file and write the name of slaves which you have defined in etc host file. Suppose you have defined like slave 1, in the next line slave 2, next line slave 3, like this. If you have defined these names in etc host file, you can write these names in slaves file and save the file. Make sure that you write one name per line. One line should have maximum one slave machine name. Okay, so let me revert the changes, otherwise my Hadoop will not work. I am reverting the changes and I am coming back to PDF. So you can add one slave machine name per line and then you can save the file. So we have modified masters and slaves file. Apart from these two files, the previous files, if you remember, we modified core-site, hdfs-site, mapred-site. We have to modify them as well. So let's move to the next slide. Next is passwordless SSH from master to all slaves. We will modify those files shortly, but before that, let's set up the passwordless SSH. Let me remind you, we set up the passwordless SSH to localhost while installing Hadoop on single system. But today, we need passwordless SSH from master to all slaves and from all slaves to master. We need that. So what we did on that day is we generated an encrypted key and we appended that encrypted key to the authorized_keys file. And after that, whenever we were doing SSH space localhost, it was not bothering us for entering the password, right? Same thing, or I would say similar stuff we will do here. Username @master. This indicates, you don't have to type that. This indicates that you have opened the terminal on master machine. If I will open the terminal on my system, it will display neeraj@myubuntu. That means username @machine name. So username @your master, it will tell you that yes, it's the master machine terminal. The point is, you will open the terminal on master machine and execute this command. SSH-keygen -t RSA -p 2 times single quotes -f tilde symbol, that's my home directory symbol, /.ssh/id_RSA. I think we no need to go into much detail of this command because this command we have already explored when we install Hadoop on multiple machines. This command is generating encrypted key, encrypted password and storing it in the specified directory. This thing we will do on master system. After that, what we will do is we will append this encrypted key on every slave. You generated encrypted password of master machine and you will append that encrypted password of master to every slave. And we will do the vice versa also. We will generate the encrypted key on slave system and will be appending to it to the master system. Ultimately, master machine's password should be available with every slave. And every slave's password should be available with master. So that whenever master wants to interact with any slave or any slave wants to interact with master, they can interact. They can communicate without bothering the user for entering the password again and again. Okay. So now let's see what we are doing. We are connecting to slave 1, SSH username @slave1 mkdir -p.ssh. As you know, when we do SSH to some system and after that whatever command we will execute, that command will be executed on that system. That's what we are doing. SSH username @slave1 make dir -p.ssh. We are still on master machine terminal, but we are connecting to slave 1 using SSH, and then we are executing a command make dir -p.ssh. Ultimately, we are creating a directory with name.ssh on slave 1. And then next command cat.ssh/id_rsc.pub, that encrypted password, then pipe SSH username @slave1. We are again connecting to slave 1. Cat redirecting to .ssh/authorize_keys. What we are doing is we are connecting to slave 1 and we are appending the encrypted password to the authorize_keys file, which is available on slave 1 system. And you can see this. Execute the below commands for every slave. Similarly, you will connect to slave 2. You will generate .ssh directory over there, and then you will append that encrypted password to the authorize_keys file on slave 2. Similarly for slave 3, slave 4, slave 5, depending upon the number of slaves you have. What it will do? It will copy the encrypted password of master on every slave machine. This is one directional passwordless SSH. We have to do it bi-directional. So what we will do? We will go to slave system. We will generate the encrypted password and we will copy that encrypted password to the master system. You can have a look. Username @slave1, that indicates that you have opened the terminal on slave 1 system. What you will do? SSH-keygen -trc -P 2 times single quotes -f tilde, that's my home directory symbol, /.ssh/id_rsc. This will generate the encrypted password on slave 1. And now what we will do? We will copy that encrypted password of slave 1 to the authorize_keys file, which is there on master system. So cat.ssh/id_rsc.pub, then pipe SSH username @master, cat redirecting to .ssh/authorize_keys. So try to understand the concept. Master machine's password should be available with every slave, and every slave's password should be available with master. And we cannot store the password directly because that can be a security breach. So before copying the password, we are encrypting it, and then we are copying the encrypted password. So friends, this is passwordless SSH between master and multiple slaves. Once you are done with these two things, you can test that. Open the terminal on master machine, type SSH space slave 1. It should connect to slave 1 without asking for the password. If it's connected, type exit. You will be disconnected from slave 1. And now type SSH space slave 2. And similarly, you can test for other systems. Since this is one-time activity, you should test it. And you can test it vice versa as well. Go to slave system, slave 1, open the terminal, and from there type SSH space master. It should connect to master system without asking for the password. If it's connected, you can type exit to disconnect from there. So this way, you can test the passwordless SSH in both the direction, so that you are make sure that the prerequisite for multi-machine Hadoop installation is completed. So after making the passwordless SSH, we'll be moving to the next slide, that is modification of configuration files. We have already talked about these files in our single machine Hadoop installation class. Let's quickly go through them again. There are minor changes. The first file is modify hadoop-env.sh file. Even in single machine installation, we had only one change. We have to simply provide where exactly Java is installed. You can open the terminal and execute the command where is space Java. There is no space between where and is. But yes, there is space between is and Java. You can execute that command, you will find the path, and we use the path before bin only. The first path is /usr/bin/java, but we are not giving the complete one. We are giving the path before bin. So export java underscore home is equal to /usr. That's the only line you have to add to hadoop-env.sh. That's all. Moving to the next file, core-site.xml. There are two properties and exactly same with a little small difference that the value of the first property, it was hdfs://localhost:9000, right? That means the Namenode service of my Hadoop is running on my local system, local system and port number 9000. But as I told you, when you are dealing with multiple machine, never ever use localhost. That's what I'm doing. I simply removed localhost and I have written the master machine name. That's all. Apart from that, there is no other change. Second property, Hadoop temporary directory. As you know, Hadoop needs a temporary directory for doing its internal things. Mapper job, reducer job, all that. So as a user, you can simply provide a directory path. And those three rules you must remember. You can give any path, you can give any name, and you don't need to create this directory. These will be automatically created the first time you will start your tool. Okay. So friends, this is about core-site.xml file. Moving to the next one, hdfs-site. Exactly same properties. Earlier the first property, dfs.replication, the value was 1. Because on one system you cannot create more than 1 copies, right? We discussed in HDFS in detail class that Hadoop is smart enough, it does not maintain duplicate copies on same system because that does not make any sense. So when we install Hadoop on single system, we made the number of copies as 1. But this time we are installing Hadoop on multiple system. If you want to maintain duplicate copies, 2 copies, 5 copies, you can do that. That's why I have made the value of first property as 2. I want to maintain 2 copies of every block, and that's fine. Remaining two properties, dfs.name.dir and dfs.data.dir. Name node and data directory. These two directories, as you know, you simply have to provide the path. You can give any path, you can give any name, and you don't even need to create this. All these directly will be automatically created the first time we will be starting our. So this is all about hdfs-site.xml. The next and the last configuration file is mapred-site.xml file. Earlier the value was localhost :9001. The job tracker service of Mapredus is running on my local system and port number 9001. This time, as you see, I have removed localhost and I have written the name of the master system, master :9001. That's the only change. So these are the 4 configuration files. As you notice that I have made minor changes. The remaining things are exactly same as we have modified in our single machine Hadoop installation. So let's move to the next slide. The next is copy Hadoop setup to all slave system. Very important part. In single machine installation, we downloaded the tar file, we extracted the tar file, and we made the required changes in the configuration file. That's fine. That's fine. But shall we do the same thing on multiple systems? I may have 10 systems, 50, 20. I cannot do that, right? Downloading the tar file on every system, making the required change on every system is not a good idea. That's a time-consuming process. That's a boring process. That's error-prone as well. You might make some changes in one system, you might forget for another. That will create some inconsistency and your Hadoop will not start. So what we do is, we download the tar file on one system, we extracted the tar file on that system, we make all the required changes on all the files on that system. And after that, what we do, that complete Hadoop setup, that extracted a directory with all the configured file, we copy to all the system using scp command. As you can see in this particular slide, scp-r. R is optional. R is required when you are copying a directory because R stands for recursive. In case you are copying a file, R is not required. scp-r, then the source path, then username @ remote machine IP or host name. through which user you want to connect to another system, and what is the another system IP or the host name, and finally the destination path. One important thing here is that this command is not for Hadoop. It's a Linux command. It's not only about copying the Hadoop setup. You can copy any other thing. You have a movie file, you have a movie, and your friend wants to watch that. Your friend is requesting for that movie. You can even copy that movie from your system to your friend's system. So SCP command is used for copying of anything from one system to another system on Linux based operating system. Okay, so for just for testing purpose, I can show you. Right now I don't have multiple systems, but what I can show you is I can show you copying the file from my system to my system using SCP command. Just like you can try sending an email from your email address to your email address. Even for sending the email to yourself, you need an internet connection, right? And your network has to follow the same process to deliver the mail to your inbox or to your friend's inbox. There is no difference. Same thing we will do here. I will copy the file from my system to my system, or from my system to another system. There is no difference. So let's try something so that you have a good idea about what is SCP. So let's choose some file and we will copy it somewhere. So I have this local cluster home directory, right? And you can see that all the directories are there. There is no file. What I will do, I will copy a file sample_hadoop.txt. I will copy this file from my home directory to local cluster home directory. I will show you this through SCP command. So let's open my terminal and we'll do it right away. So we'll type SCP. Since it's a file, -r is not required. Or to be on safer side, you can write -r so that you are not bothered whether it's a file or it's a directory. You can type -r. SCP-r, then the source path /home/nearest/sample_hadoop.txt. That's my local file, local path. Now the username through which I will be connecting to another system. Right now I am connecting to my system with my username, so I will type nearest@localhost and colon, then the destination path where exactly I want to paste it. So I want to paste it on /home/nearest/local cluster home. That is the directory inside which I will copy. That's all. This is a complete command. SCP-r, source path, username@remote machine IP or the name, colon, destination path. I will press enter now and file will be copied. You can see that. The file name sample_hadoop.txt. The percentage of progress 100%, size of the file 123 bytes, the rate of transfer 0.1 KB per second, and approximate time 0. The file was quite small, not even in KB, in bytes. That's why approximately in no time it has been copied. Shall we verify it is really copied or not? Let's check it out. We'll go to our folder structure, we'll go to our local cluster home, and you will find the file sample_hadoop.txt. I have successfully copied the file from my system to my system. If you have to copy to other system, the only difference is that host name. I provided username at my machine name. In case I want to copy it to a Yogi's machine, I will type username@Yogi's machine IP or the host name. That's all. So logically there is no difference. So friends, this way we will copy the complete Hadoop setup. Suppose this is my Hadoop 1.2.1. This complete directory we will be copying on every system. So one command will copy on one system only. That means if you have 10 system, you have to execute 10 commands. One command will copy from master to slave 1. Second command will copy to master to slave 2, and similarly for other system. You can do that and you will be able to copy the complete setup on every slave system. So with this slide we are almost done with Hadoop installation on multiple machines. It's time to start our. So before starting, we need to format the name node, and that's one time activity. We don't need to do it every day. Even we have done that for single machine installation. Now for multiple machine installation, we will do it. And we will do it only on master system. Open the terminal on master machine and type this command /hadoop Namenode -format. It will display a lot of things, but we will look for some success message. /home/nearest local cluster home Hadoop 1.2.1 hdfs-metadata has been successfully formatted. Some success message is displayed. That is making sure, that is giving me the guarantee that yes, my formatting command is successfully executed. That's good. And now we are ready to start our. Interesting part is there is no difference in the command. Even for single machine, we typed start all.sh, right? Which started all the services, all the master services and all the slave services on the single system. But this time, we will do start all.sh from master machine's bin directory. No need to go to slave. No need to start anything separately on slave system. That's not required. You can just relax on master system and control everything from master. So from bin directory of master, you will type start all.sh. I have specifically mentioned no need to start anything on slave system. This command is smart enough to start the required services on master as well as on slave. And passwordless SSH is already there. So master machine will give instruction to slave system to start the required services. So whatever it will do internally, let's do it. Ultimately, the single command will do all the services for you. You can verify that. You can open the terminal on master machine. You can see the above screenshot. Nearest @master indicates that this is master machine's terminal. I am typing JPS. It's displaying job tracker, secondary name node and name node, because these three are my master services. These three master services are running fine on my master system. That's good. For slave services, I have to go to slave system. We'll go to slave 1, open the terminal, type JPS, and you can see task tracker and data node services are running, because those two are my slave services. Similarly, I will go to slave 2, slave 3, slave 4. I will do JPS over there, and I can verify whether all the required services are running on all the systems or not. If you find something wrong, suppose data node service is not running on slave 6, on that same system, inside the logs directory, you will find the log file for data node. Open that and try to understand what is the issue. Maybe you forget to install Java on that slave 6. That's possible. So log file will help you to understand the issue. Any system which is not displaying the required services on that system itself, go to the log directory, open the corresponding log file and try to understand the issue. Accordingly, you can fix that. So friends, this is all about how to start Hadoop. And as far as the commands are concerned, copy from local, copy to local, and executing of word count, executing of any MapReduce job, removing the file, there is no difference. One thing is there, earlier your data was stored on single system and only one system was processing your data. This time multiple Ubuntus will be storing your data and multiple Ubuntus will be processing the data. But that's something internal. As a user, you have to execute the command exactly in the same way you are executing on single system. Once you are done with your practical stuff, it's time to stop your Hadoop, and you can type this stop all.sh. It will be stopping all the services on master machine as well as on all the slave machine. You don't need to stop anything separately on any slave. It will stop everything. After that, if you want to verify, you can type JPS. That will display only JPS. No other Hadoop services are displayed. That simply means that your Hadoop has been successfully stopped. So friends, this is all about Hadoop installation on multiple machines. Hope you are clear on the concept and you are also clear what's the difference between single machine Hadoop installation and multi-machine Hadoop installation. These steps are properly tested and verified. That means in case you get a chance in your office to install Hadoop on multiple machines, you can follow all these steps. Using these steps, I have installed Hadoop multiple times on multiple machines in my office. So friends, that's all for today's class. Thank you.